coming to you live in Map 10. Okay, so we're doing geometry lesson 3.1 today, so let's go ahead and get started. I gotta turn off the music, sorry. Okay, so let's get started. 3.1. Okay. Alright, so identify pairs of lines. Well, I think some of this you've had before in the past, so hopefully this will review for the most part. So our objective today, students, will identify angles that are formed by two parallel lines and a transversal. One of the key words here in this lesson is the transversal idea, and so we'll be going over that shortly here. What types of angles are formed? And these sorts of angles are used in construction all the time, so anyhow, probably a good idea to know what kinds of angles there are. And we have these types of angles anytime we have parallel lines. So, well, let's get started. Alright, so here's just some basic information. Here's a diagram that kind of shows parallel lines, but they also show what's called skew lines. And so most of you probably know what parallel lines is. Kind of like railroad tracks. If you go across railroad tracks, you'll notice the railroad tracks do not intersect, or at least they're not supposed to intersect. And so, example parallel lines are these lines here. There's line N and line M right here. Now notice there's a symbol we use for parallel lines. It's this symbol right here. This little arrow thing. And to be quite honest, I usually draw them a little bit different. Like if I have parallel lines here, I might have parallel lines, and I'll just put this symbol like that, just this arrowhead type thing. Anyhow, that indicates parallel. Now when we're writing out things, there's a symbol we use for parallel, and that's that symbol right there. So it looks like, let me write it a little bit larger here, that looks a little blurry. We would say line M is parallel to line N in this case. So that's what we have there. Now we also have what are skew lines. Now skew lines don't intersect either, but here's the deal. They are in different planes, so to speak, or they're going, I shouldn't say it, they're non-coplanar. And so this line M, for example, and this line K, you can see that they don't intersect either, but they're not in the same plane, and so they are what we call skew lines. Okay, if they do not intersect and they are not coplanar. Notice these two lines are in the same plane, they're in that blue plane. So that's the difference between parallel lines and skew lines. Well, at the same time we can talk about parallel planes. I think that's pretty obvious. Two parallel planes would be two planes that don't intersect, kind of like this green one and this red one. So anyhow, well, so we have some basic ideas about parallel and skew. Okay, so there's that symbol again. Okay, so we have a famous postulate. It's called the parallel postulate. It says, basically, and there's a lot of history behind this, it says that if you have a given line L and you have a point here, a point P, then you can always draw a line parallel to the given line. And so let's see this in action again. You start off with the line L like this, and you have a point P anywhere that's not on the line, and just put it here. And what we're saying is that how many lines can you draw parallel to the given line? Well, what we're going to say is that there's exactly one. There's only one line that's parallel that passes through that point P and is parallel to the given line. You see? Now, imagine my line straight. You see? So there's the parallel symbols, like that. Okay, so there's exactly one. In other words, you can't draw a second line that's parallel, you know, like this, you know. This line, it would turn out to be, it would intersect somewhere down here. You see? So, anyhow, we have a postulate that says, hey, through any point, there's exactly one line that's parallel to the given line. We're going to see this idea later on in another lesson. So, we have a related postulate that's called the perpendicular postulate. And it basically says the same thing as the previous one, except for there's only one perpendicular line that passes through P. You can't have a second perpendicular line that kind of comes through right here and is also perpendicular. You see, we could have at most one perpendicular line that passes through P. And this turns out to be the way that we're going to determine distance. Anytime you're trying to measure a distance to a line, you would naturally take the shortest path. And if you take the shortest path to this line, it's going to be the one that's perpendicular right here. Naturally, if you took a different path, it'd be longer. That'd be longer still. The shortest path to this line is always going to be a perpendicular line. So anyhow, that's another related idea. The parallel postulate says there's exactly one point that's parallel to the given line. This one says there's one point that's perpendicular to the given line, and so on and so forth. Well, kind of went through that fast, but let's talk about transversal. A transversal is a line that intersects two or more coplanar lines at different points. Well, now here's the deal. Since you have the definition, see if you could take a moment and draw this on your own paper. This is good practice. Lots of times people get a manual and they're trying to figure out how to do something. They have the directions right there in front of their face and they can't seem to follow the directions. So here's a good reading comprehension type thing. Read the definition again. See if you can draw a picture. Again, it's a line. So that's the first thing. You start off with a line. And it intersects two or more coplanar lines at different points. You know, so you might have to play with this a little while. Just, you know, play with it. See if you can figure it out. So take a minute and do that. Okay, well, I have an example as well. Let's see if yours is like mine or if we agree of some sort. You start off with a given line, okay? Well, it's got to intersect two other lines at different points. So, here's a line that goes through here. Okay. Now, the other line that intersects has to intersect at a different point than this one. So we have one intersection point already. And let's draw another line that intersects. Alright, it just has to be at a different point. Here's another intersection point. So let's check out the definition. It says transversal is a line. The line that I'm talking about is this black one right here. There's my transversal. Okay. It intersects two or more coplanar lines at different points. So the key is that they're at different points. What we cannot have is this scenario where it crosses here at that same point. That is not a transversal anymore, at least through those 2 points. Transversal has to cut two lines at different points. So let's take that line back off of there. Do that. Isn't that cool? So there you have it. Now, here's the deal. Every time you create a transversal, there's going to be a group of angles. There's a group of angles associated with this intersection, and there's a group of angles associated with this intersection point. Like, for example, we have 1, 2, 3, 4. There's 4 angles surrounding this intersection point. There's another 4 angles that are connected to this intersection point. So we have like 5, 6, 7, 8. So we have a group of 4 here and a group of 4 here. So You always have that, like when you have a transversal. So we'll be watching out for that. Because in just a few moments we're going to talk about some special angles. Okay, so let's talk about these special angles. There's 4 types of special angles we're going to talk about, and one of them is corresponding. The key for corresponding angles is that they have the same position. So think same position. Same position. Now here's the deal. When we talk about these 4 angles, there's a group of 4 angles down here, and there's a group of 4 angles down here. Now, these 4 special types of angles that we're going to talk about, we always take one angle from this group and one angle from this group. And so in this case, the angle that we're talking about up here, we would say it's on the right side of this intersection, and it's on top. You see, we would describe that angle, it's on the right side, right, and it's on top, right? Does that make sense? Okay, so now what we're going to do is get from this group of 4, we're going to find the angle that's in the same location. We need to pick the angle that's on the right side and on the top, you see? And that angle there is the one that's there. It's on the right side and the top. Now, later on, we're going to make this more complicated. We're going to put all 4 angles in here. 1, 2, 3, and 4. And we have another set of angles down here. 5, 6, 7, 8. Now, we're going to, so if we're talking about angle 2, well, the corresponding angle that's in this group is this one. Because, like I said, once again, it's on the top right side. Now, there's another group of corresponding angles, for example, this angle. This angle's on the, if you consider this intersection point, it looks like to me it's on the left side of this transversal. Transversal is right here. There's the transversal. I'll use a capital T for transversal. It's a transversal going here, so this is on the bottom left side. So the corresponding angle with this angle would be this one, because it's on the bottom left also. Do you get it? So these 2 angles right here would be corresponding. Well, there's another pair. This is a bottom right, bottom right. This is a top left, top left. So there's several corresponding angles in this diagram that we have. So we have our first type of angles, corresponding. Another type of angle are alternate interior angles. So let me explain how this works. When we say alternating, it means that we flip sides of this transversal. Transversal is going here, and it looks like to me that we have a left side and we have a right side. We have left and we have a right side. Okay? So alternating angles are always going to be one on one side of the transversal and one on the other side. Now, what's this part interior mean? Well, remember when we were talking about the interior of an angle, where we had an angle like this, and remember what I said? How can you talk about the interior angle? Well, you can pick any point you want on this ray. Say that one. You can pick any point you want on this ray. Say this one. And you can connect those 2 dots, make a segment, and that entire segment would lie on the interior of the angle. Interior. And so you have a whole bunch of interior spots. I mean, all this spot here, all this area right here would be interior of that angle. Well, the same idea here arises here. If you pick any point on this line and any point on this line, and you connect them, then that whole blue segment would be on the interior of those 2 lines. Does that make sense? So this is interior, 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 interior. That's all interior. So this whole section right there is the interior. Okay, so you might be able to guess this now. If this blue section is the interior, where's the exterior portion? Well, as you might imagine, the exterior is the part that's out here, you see, and this part out here. So the part that's between the two lines is the interior, the part that's outside is the exterior. Okay, so now do we understand the final picture here? Why do we say that these are alternate interior? Well, because first of all, it's you got to take an angle from this group and an angle from that group. Okay, one from each group. And it's got to be on the interior portion, so that's in between here. Okay. And so once you take this angle here that's on the interior, there's this angle over here that's also on the interior. Take a look at this. So this is a little bit confusing here. This angle is, you know, if you look at this intersection point, there's an angle right here also. I'll call it number 6. This angle is also interior. And there's an angle down here that's interior. I'll call it angle 7 for the time being. But remember, when all these types of angles we're talking about, we have to take one angle from this group and one angle from this group. And in this case, we have to take the alternate interior, so it has to be on the opposite side. So that means 4 and 5 are alternate interior angles, but it also means that 6 and 7 are alternating interior, because they're in the interior portion and they flip sides. And one of the angles is from this top group and one of the angles is from the bottom group. Okay, so let's continue with the alternate exterior angles. You see, so here's the repeating idea again. We have an angle from this group, an angle from this group. The exterior area is this part out here. There's another exterior area out here. And remember, you have to flip sides. So if you pick angle 1, you have to take an angle on this group down here. And there's only 2 exterior angles, and it can't be on the same side. You see, if we pick that angle right there, it would be on the same side as 1. It has to be an alternating angle, so it has to be on the other side, which means it's this one right there. You see? So 1 and 8 are alternate interior angles, but I might add, there would be another pair of angles that would be alternating. And that would be this pair here. We call this angle 2, call this angle 7. 2 and 7 would also be alternate exterior angles. Okay, so we have one more group of angles, and these are consecutive interior. Okay, so how does this work? I actually like a better name for this. I often call them the same side interior. That's what back when I used to teach this a long time ago at Hermiston High School, they used to have the textbook, they would call them the same side interior, and I kind of like that description better. But let's go ahead and go over it real quick. First of all, it has to be angles on the interior portion, so that would be this black section here. But here's our transversal, so you can pick 2 angles that are on the same side, which would be 3 and 5, or you could actually have 2 angles that would be on the opposite side, like 4 and 6. 4 and 6 would be same side also. So it's either going to be on the left side or on the right side in this case. You see, so that's why I like same side interior. Your book calls these consecutive angles. Consecutive usually means one right after another. And so, in my opinion, I think that's a little bit confusing. But here's how you can think of it. Think of it this way. As you're going around this way, this is an angle you come across, and then you come across another angle as you move around this way. As you move around this way, you'd have 2 consecutive angles also. You're coming across this way and you create an angle right there, and then you come down here and you create another angle. So that's how the angles are consecutive in a sense. As you move around this way or you move around this way, you come across 2 angles, one right after another, as you move around this little diagram. I think that's a little bit more confusing, but anyhow, I like, well, look at what they do. They say in the description, they say it's the same side of the transversal. So I kind of like the idea of calling them same side interior angles. So you might hear me say that from time to time instead of saying consecutive interior angles. Okay, so let's recap. We have 4 special types of angles. We have the corresponding angles. They're in the same position. We have alternating interior. They have to flip sides, and they're on the interior portion. They have alternate exterior. They're on the opposite sides of this transversal, and they're on the exterior portion. And then we have the same side or consecutive interior angles. Now here's the thing. Always remember, when we're talking about these special types of angles, that you always take one angle from this group up here and one angle from this group down here. One angle from up here, one angle from this group down here. And once again, one angle from each group. One angle from each group. So there you have it. We have the 4 special types of angles. And now you're just going to have some practice problems where you're identifying which angles are which. So let's go ahead and practice this a little bit. Now, this time our transversal is going this way, but notice the transversal has to intersect at 2 different points. There's a single point there and there's another point there. And whenever we go through naming these angles, we have to identify the groups from one from each group of angles. So let's start off with corresponding angles. Okay. We want to list all the possible corresponding angles. Well, let's start off with this left group. We'll start off with angle 1. And remember, corresponding angles have to do at the same position. And if you notice, this angle 1 is on the left side and it's on top. And so it's on the left side and it's on top. Okay. Left side and on top. Okay. Well, so then you want to pick the left side and the one that's on top of over here. So that'd be angle 5. So what we'd say is angle 1 and angle 5. Well, as you might imagine, that's not the only answer. Well, how about angle 2? Angle 2 is on the right side and it's on top. So angle 2 is on the right side. And which one's on the top right? Well, it's angle 6. Angle 6. Alright, well, let's continue. Angle 3 has a corresponding angle. It would be 3 and 7 because it's on the left side and it's on the bottom. And the left side on the bottom would be angle 7. So angle 3 and angle 7. And how about angle 4? We have angle 4 and its corresponding angle that's in the same position as angle 8. And so there's 4 sets of corresponding angles. So we've done part A. How about part B? Okay, change colors here. B, we want the alternate interior. Now in this case, the interior would be this region. Okay, it's the part that's between the 2 lines. That's what we call the interior. Well, so if I take an angle from this group, I'd have to use either 2 or 4. And from this group I have to use 5 or 7 because those angles are on the exterior. You see? Those angles are on the exterior portion. So I have to use the interior angles only. Well, so if I take 2, I have to take 7 with it because it has to alternate. One has to be on one side of the transversal and one has to be on the other side. So angles 2 and 7. Well, that means 4 and 5 are also alternate interior angles. And now let's do part C. Part C, we're looking for the alternate exterior angles. Well, now we're talking about the exterior portion, which is the part that's on the outside. And so now we don't care about these guys because they're on the interior. We don't care about those guys. Okay. These are the only two that are on the exterior, and these are the only two on this side that are on the exterior. So if I take angle 1, I have to take angle 8, because again, you have to flip across the transversal each time. If you're alternating, you got to flip sides. So angle 1 and angle 8. And as you might imagine, if I chose angle 3 instead, I'd have to choose angle 6. So angle 3 and angle 6. And finally, let's do part D here. We want the consecutive angles. Alright, but they're interior angles. So the consecutive angles, well, it means we don't care about those because those are on the exterior side. Okay, so we don't care about those. And they have to be on the same side. Now remember, they have to be on the same side of the transversal. Now you might be tempted to say angles 2 and 4. But the transversal that we're talking about is actually this line. This is the transversal. There's the two intersection points, you see. This line here is not a transversal. It only intersects at one point. This is not a transversal either. So it's not 2 and 4. In this case, it has to be 2 and 5. They're on the same side. And in this case, they're on the top side. So we'd say angles 2 and 5. Angle 5. Okay. And then there's two that are on the bottom side together. Angles 4 and angle 7. Alright, so make sure you don't get this mixed up. Make sure you keep track of which one's the transversal. The thing that can make this kind of difficult at times is that sometimes you have more than one transversal in a diagram. Let me just show you real quick how that could work. You could have a couple lines here. Alright, you have a line here. Here's one transversal and here's another transversal. And there's multiple transversals in this case. Remember, to be a transversal, you just have to intersect two other lines at different points. Well, that means that this here is a transversal. There's transversal number 1. This also is a transversal because it crosses two different points. Two other lines. There's an intersection point there, and there's an intersection point there. So there's like number 2. This one would also be a transversal because it crosses this line and this line. So there's number 3. And lastly, this one is also a transversal because it crosses two other lines at different points. So in this diagram, there's 4 transversals and there's a whole bunch of angles. And so once you have a diagram of multiple transversals, things can get a lot more confusing. And so you got to keep track with respect to whichever transversal you're dealing with. And so, like for example, if this is the transversal you're talking about, then this portion right here would be the interior. Okay? But if you're talking about transversal number 2, okay, then this portion would be the interior. Okay? So as you might imagine, it gets a little bit confusing when there's more than one transversal. Anyhow, let's go ahead and try it on your own here. See if you can identify the types of angles here. I'll let you go first. About 30 seconds here, and then I'll give you the answers. See if we come up with the same thing. Okay, well for this one, I notice that angle 1 is on the left side and it's on top. This is on the left side and on the top. Notice there's the two intersection points. They're on the same side, left top, left top. So I'm going to say they're corresponding angles. Corresponding. Alright, well how about this one? If this is my transversal right here going along this way, then this portion here would be the interior portion, And so angles 2 and 7 are on the exterior portion. And notice 2 is on the, well, it's kind of on the top right side. 7's on the bottom left side. So we did what we did to get these two angles. We flipped across that transversal. So that means these are alternating angles and they're on the exterior. So these are alternating exterior angles. And I'm going to start abbreviating alternate exterior angles. And finally we have another alternating because we flipped across this way, okay, and this time we're on the interior portion. So these are called alternating interior angles. And once again, I'm going to abbreviate alternating interior angles. And so there you go. We have some practice naming these types of angles. So we're finally up to our essential question. What angle pairs are formed by transversals? Well, we have corresponding angles, alternating interior angles, alternating exterior angles, and we have consecutive interior angles. So all we're doing in this first lesson is practicing identifying these types of angles, because we're going to build on this in the next section. We're going to learn some theorems about these types of angles, especially if we have parallel lines. Some special situations come up. So stay tuned for tomorrow for the next lesson.